implied by the large distance. So it even more makes it so that it's such a large distance away, which means that this thing is really luminous. It's quite extraordinary. It's not a normal kind of luminosity. A quasar a quasar is an AGN that has a very high luminosity. So again, AGN is active galactic nucleus. Let me put that in the chat. Active galactic nucleus. Yes, I do some singing sometimes. I can do that today as well, later on, but I gotta answer the question about quasars first. We first do the serious stuff. So what was extraordinary? So again, I put that in the chat, active galactic nucleus, or AGN. What was extraordinary was the luminosity implied by the large distance. A quasar is an AGN that has a very high luminosity, where the luminosity is now 10 to the 38 watts or so. The most luminous known quasars have around luminosity of 10 to the 41 watts, or which is around 3 times 10 to the 14 luminosities of the sun. So 3 times 10 to the 14, that's quite a bit of solar luminosity. The reason why they look quasi-stellar, so quasi-star-like, is that quasars are much more luminous than the sum of all the stars in the galaxies that contain them. So it's like the active galactic nucleus itself is giving off so much luminosity that it's like a really bright point-like thing at a very large distance, making it seem like a star more than a galaxy, which we would consider to be a more extended body of brightness, right? So the quasar, the reason why they look quasi-stellar is that quasars are much more luminous than the sum of all the stars in the galaxies that contain them. Thus the quasars usually appear like unresolved points of light, just like stars. It's initially difficult to believe that the highest and lowest luminosity AGNs represent the same phenomenon. Indeed, as we'll describe, the energy requirements needed to explain quasars were so radical in the 1960s that a 20-year controversy over the nature of quasars ensued. Are they high luminosity versions of safer galaxies at the large distances implied by their redshifts? Or are they low luminosity nearby objects of some sort with their large redshifts due to some other effect than the expansion of the universe? For most astronomers, the matter was settled definitively in favor of the former hypothesis in the 1980s, with the detection of stellar absorption features in the faint fuzz surrounding quasars. The remarkable properties of quasars soon led to more efficient ways of discovering them. For example, quasars are very blue compared to stars. So they looked like stars, but there were some odd properties that sort of gave them away as maybe these are something different. You know what I mean? Like it's almost like thing after thing being discovered about them is making them more and more confusing and hard to resolve, quite literally, as stars. Okay. Okay, I'll keep going. The remarkable properties of quasars soon led to more efficient ways of discovering them. So because these things are so different than stars as well as galaxies, because they were too radio loud to be stars, and they were too point-like and luminosities too in the nucleus of them to be normal galaxies. So it's like, what are they?